Hello everyone, this is part 2 of the method of partial fractions. So for the case 2, we consider that q of x is a product of linear factor, some of which are going to be repeated. So in arrangement p over q, that means that q can be seen as the same factor repeated a couple times plus some other terms that are going to be just repeated once. Then we can just write that arrangement of p over q as a bunch of fractions where we're going to do one fraction per each of the powers of the repeated terms. So for example, if we have that one term is repeated r times, then we get the first term power 1, power 2, plus up to power r. And then after that point, we start doing all the other factors that are involved in the fraction. Now, let's see that more clearly with some examples. So, we're going to see the following integrals: 1 over x minus 2 squared, and another one here. So pay attention to this. When we have 1 over x minus 2 squared, we can arrange this in different ways. We can start with the ones that they do not repeat. So for example, a over x, and then we'll go over the next one, b over x minus 2. Initially with no power, then the next one is going to be x minus 2 squared. Now let's assume this will be x minus 2 to the 5. Instead, then I will have to continue dx minus 2 to the 3 plus ex minus 2 to the 4 plus fx minus 2 to the 5. Okay, I need to make one fraction per every single one of the exponents that I have in here. Okay, up to reaching the power that I have over here. Then once that I have this arrangement, then the procedure is the same. I continue, well, then 1 is ax minus 2 squared plus b is x minus 2 plus cx. And so I can give values now to find the constants. If x is equals 0, this goes away, and then I get 1 equals 4a. So a is equals 1 over 4. And if I give x equals 2, then I only get 1 equals to c, and then c is equals 1/2. And if I'm left or if I'm out of roots, then I can pick another easy value that is going to help me out find this quickly. So for example, x equals 1. I have 1 is equals, and I already have a, so this is 1 over 4 minus 1 squared. Plus b, and then this is 1 and minus 1, and then plus c, which is 1/2 times 1. So I have this. Okay, so simplifying here, this is 1 over 4, or I'm going to write 1 over 4, 1 over 4, and this 1/2 I'm going to write it as 2 over 4. And then I'm going to write here minus b. Okay, so that implies that b is equals to 3 over 4 minus 1, which is 4 over 4, by the way. So this means that b will be minus 1 over 4. So my partial fraction decomposition will be given by this, and this integral becomes the integral of 1/4 of 1 over x dx plus, or actually minus, 1 over 4 1 over x minus 2 dx, and finally c plus 1/2 of 1 over x minus 2 the square dx. Okay, and so of course I can finish my integration here. This will be 1/4 of log of x, absolute value of x, minus 1 over 4 log of absolute value of x minus 2. And this is like a situation where I have u to the minus 2. So this is going to become u to the minus 1 over minus 1. And so this becomes this when I integrate by substitution this term. And that's the end of this particular example. So now let's move to another example. Let's go back to see here we have the integral of x to the 4 minus 2x squared plus 4x plus 1 divided by x cubed minus x squared minus x plus 1. Notice that in this scenario we have that the numerator is bigger than the denominator, so we're gonna have to do long division. So the first step is we do long division between these two. And so when we do the long division between these two, we get that this is equals to x plus 1 plus 4x over x cubed minus x squared minus x plus 1. And then notice that now this piece is something that I'm going to be able to easily integrate, and this piece is what's going to be left for partial fractions. And so at this point, partial fractions, 4x over x cubed minus x squared minus x plus 1. I need to factor the bottom. And so when I'm factoring the bottom, notice that I'm going to get that this is x minus 1 times x squared minus 1, or this is 4x, x minus 1 squared, x plus 1. So now I have another repeated term of order 2, and I can rearrange this as a over x minus 1 plus b x minus 1 squared plus c x plus 1. Now again, if we multiply by the common denominator on both sides, then we're going to have that 4x is a x minus 1 x plus 1 plus b is going to be times x plus 1 plus c x minus 1 square. And then we can give, of course, different values to find out things. So for example, if I do x equals 1, then I'm going to get that 4, and this goes away, and this goes away. It's going to be 2b, and so b is equals 2. And if I do x equals minus 1, then this term goes away, this term goes away, and I get that minus 4 is equals here, this is minus 2 squared, which is 4, so 4c. So that implies that c is equals minus 1. And then last but not least, then we need to find out the third value. And so we can do that by plugging a different number. The most easy number to probably plug is 0. So this is going to give me 0 here. And then I'm going to get minus 1 and 1 here. So I'm going to get minus a. And then plus. And if I do b, remember b is 2. So a plus 2. And then plus c, but c is minus 1. So So this is 2 minus 1. So essentially I'm going to have that a is equals 1. Okay, and so given that those are the results of the fraction, then I can have that this integral here is going to be the integral of x plus 1 dx plus the integral of 1 over x minus 1 plus twice the integral of 1 over x minus 1 squared plus, and then c is minus 1. So let me put a minus here instead. So first let me not forget the dx, and then minus 1 over x plus 1 dx. And then of course I complete the integration here. This is x squared over 2 plus x from the first integral, then plus log of absolute value of x minus 1 plus or actually minus 2. Okay, so this is going to produce me a minus here. So minus 2 over x minus 1, and then minus log x plus 1, and then of course plus c. And that's it. So as you can see, a lot of the complicated parts of the partial fraction method is that we gotta find out the right factorization, the right arrangement, find a constant, but integration, once that we complete that, is actually very easy.